There, Mr. Sutton here, bringing you the Algebra 2 11-2 Part 2 homework solutions on analyzing arithmetic sequences and series. Figure out a rule for the nth term of this arithmetic sequence. We're going to have to figure out the a1, the initial term, and also the d value, the common difference. Let's start by getting the d value, and then we'll talk about that initial term. So for the d value, I basically need to do the slope formula. So we're going to do a of 21 minus a18 over 21 minus 18. So negative 71 minus negative 59, so plus 59, over 21 minus 18. Basically the slope formula in sequence form. So we've got negative 12 over 3, which I can reduce to negative 4. And at this point, I'm going to find the a1 value. To do that, let me first write my nth term formula, because that's going to be helpful. So we have a sub n equals a1 plus d times n minus 1. And this is actually what we'll be plugging everything back into toward the end of the problem. But for now, we're solving for this a1 value. So I'm going to plug in one of these points for an and n, along with the d value they gave me. So I'll use the first point. I usually do here. So we're going to use negative 59 for a sub n. For a1, we're solving for that. For d, we've got negative 4. And for n, since I'm using negative 59, I have to use the input value of 18 for n. All right, let's clean this up a bit. 18 minus 1 is 17, times negative 4 is going to be negative 68. And then to get a1, I have to add 68 to the other side. So that's going to give me a sub 1 value of 9. All right, so let me plug this in with my d value that I found earlier into my nth term formula. So we have a sub n equals a1 value of 9 minus 4 times n minus 1. And let me simplify this. So we have 9 minus 4n plus 4. And then 9 plus 4 is 13, so negative 4n plus 13. To find a rule for the nth term of this arithmetic sequence, since it's arithmetic, that means it has a common difference. Let's go ahead and find that. Since these terms are not right next to each other, I basically have to use the slope formula in order to get the common difference. So we're going to do y2 minus y1, so 94 minus 58, over the difference of the inputs, so 11 minus 7. This is 36 over 4, which I can reduce to 9. So I have my d value. In order to write my general nth term formula, I also need the a1 value. To get that, let me actually write my an formula, a1 plus d times n minus 1. So in order to get this a1 that I need, I'm going to plug in the d value that I just found, along with one of these terms and the index that I used to get that term. So I'm going to use this first term here because, well, why not? So for a sub n, I'm going to use 58. a1 I'm solving for. d I've got 9. And for the n value, since I'm using 58, that means I have to use the index 7 for that n. So we've got 7 minus 1, which is 6. 9 times 6 is 54. And then to get a1, let me just subtract that. So a1 would be 4 then. And now I'm ready to plug all of that back into my a sub n formula. So a sub n equals 4 plus my d value of 9 times n minus 1. And just one more little thing. I need to simplify this a little bit. So we've got 4 plus, distributing here, 9n minus 9. 4 minus 9 is negative 5. So 9n minus 5 then for my final simplified answer. In order to find a rule for the nth term of this arithmetic sequence, since it's arithmetic, I might as well find the common difference first. Since these terms are not right next to each other, I can't just subtract 15 minus 9. I mean, I need 15 minus 9, but I also need the difference of the indexes here, 27 minus 12. This is basically the slope formula, y2 minus y1 over x2 minus x1. So this is going to be 6 over 15, which I could reduce if I wanted to 2 over 5. All right, so I've got my common difference. I also need my a1 in order to fill out the formula. That's this formula here, a sub n equals a1 plus d times n minus 1. So in order to get a1, I'm going to plug in the 2/5 I got for d, along with one of these two terms for my an and my n value. So I'm just going to pick my first term. It looks a little easier to deal with. So for a sub n, that's going to be the output of this term, so 9. And then a1 is still a1 plus my d value of 2/5. And for my n value, I'm using the index that got me 9, so that would be this 12 right here. So 12 minus 1. 12 minus 1 is 11. 2/5 times 11 gives me 22/5. In order to get my a1 value, I have to subtract this over to the other side. So I'm just going to pretend that this 9 is, well, let me see, if I multiply by 5 over 5 for a common denominator, this would be 45/5. So 45 minus 22 would give me 23/5 for my a1. All right, let me plug all this back into my a sub n formula. So we have a sub n equals my a1 of 23/5 plus my d value of 2/5 times n minus 1. And I don't want to, but I need to simplify this a little bit more. So let me distribute this 2/5. That's going to be 2/5 n minus 2/5, which actually wasn't horrible. But I need to combine the 23/5 and the negative 2/5. That's going to be 21 over 5. So 2/5 n minus 21/5 gives us our final answer, or plus 21/5. On this problem, I am trying to figure out the sum of this sequence. Now, since this is a linear summand here, that means that we're going to have an arithmetic series that's going on with this one. So that means I can use the sum of an arithmetic sequence. That's n times a1 plus a sub n all over 2. So let me just find n, a1, and an. N is going to be the number of terms. Since I'm starting at 1 and going to term 26, there's actually 26 terms total, so n is 26. For a sub 1, I just have to plug 1 into my summand here, so 4 times 1 plus 7. That's 4 plus 7, so 11. And then for a sub n, I have to plug in this 26 to my summand, so 4 times 26 plus 7. That's 104 plus 7, so 111. All right, so putting that all together, I've got 26 times 11 plus 111 all over 2. And I'm just going to run that on the calculator. So let me make a fraction here. We've got 26 and 11 plus 111 all over 2. Comes out to 1,586. For this problem, we're trying to find the sum of this series here. Now, since the summand of this series is a linear formula, it's got the highest is the first power here, that means that this is going to be an arithmetic series because of the linear pattern. So we can use our arithmetic sum formula, n times a1 plus an over 2. So let me get the different pieces of this. N is the number of terms. Since we're starting at 1 and ending at 31, 31 terms in this one. For my a sub 1, I just have to plug 1 into my I in my summand, so negative 3 minus 4 times 1. That's negative 3 minus 4, so negative 7. And then for a sub n, that's 31 plugged into this formula, so negative 3 minus 4 times 31. And let me just do that on the calculator just to be on the safe side. So negative 3 minus 4 times 31 is negative 127. So plugging all of this in, we're going to have something over 2. Got that fraction of 2. And we're going to have an n value of 31 times negative 7 minus 127. All of that over 2. Let's go back to the calculator and plug all that in. So new entry here. Let me make a fraction. We have 31 parentheses negative 7 minus 127 all over 2. Gives us negative 2,077. Yeah, no way I was doing that one in my head. In order to find the sum of this series, let's see if it's a special kind of series. So I noticed that we have a linear function in here. Since it's a linear pattern, that means we're going to have an arithmetic series, which means I can use my formula for those. S sub n equals n times a1 plus an over 2. So let's find n, a sub 1, and a sub n. N is the number of terms. We're starting at 1 and going to 41, so that's a total of 41 if you count them up. And then to get a sub 1, we're going to plug 1 into my summand, so negative 2.3 plus 0.1 times 1. That's negative 2.3 plus just 0.1, so negative 2.2. And then a sub n is going to be all of this stuff with 41 plugged in instead, my highest term. That's going to be negative 2.3 plus 4.1, which is 1.8. Putting it all together then, the sum of the first 41 terms will be a bunch of stuff over 2. The stuff is going to be 41 times negative 2.2 plus 1.8. And let me plug that in the calculator just to be on the safe side. So let's make a fraction. We've got 41 and negative 2.2 plus 1.8 all over 2. Comes out to negative 8.2. For this problem, we have a marching band arranged in rows. First row has 3 band members and each subsequent row has 2 more than the last. So we want firstly to get a rule for the number of band members in the nth row. Well, the key here is that we have 2 more band members than the previous row for each row we go forward. So we essentially just keep adding 2 over and over again, which makes this an arithmetic sequence. So to get the nth term of an arithmetic sequence, we've got our formula, a sub n equals a1 plus d times n minus 1. We just need to figure out the a1 and the d for this one. So a1 is the first row, which they told us was 3, so that's pretty straightforward. For the d, that's how many we're adding to get the next row. It's the common difference. They told us that each row has 2 more than the row before it, so d value in this case would be 2. So then we end up with 3 plus 2 times n minus 1. And if we want, we can simplify this. So this would be 3 plus 2n minus 2, or just simply 2n plus 1. So that's my nth row. Now, how many are in a formation with 7 rows? Since this is based off of an arithmetic sequence, this is going to be an arithmetic series, which means I can use my arithmetic series sum formula. S sub n equals n times a1 plus an over 2. For my n value, we've got 7, and actually 12, no, 7. There we go. I don't know where the 12 was coming from. I'm sure we don't have that many band uniforms. So we have n is 7 and a1. That's going to be the first row, which again was 3. We already knew that. A sub n in this case is a sub 7. So we have to do 2 times 7 plus 1 using this formula up here. So that's going to be 15 band members in that 7th row. So plug in all that in. We've got 7 times 3 plus 15 all over 2. And I'm pretty sure we can do this without a calculator. 3 plus 15 is 18, divided by 2 is 9, and then 7 times 9 gives us 63 band members in the whole formation.